Today we want to talk about making a claim concerning the mean of a population, a claim about mu. So we're right over here. Now, we might know the population standard deviation, but it's really unlikely that we would. So we're going to be using a t-distribution. T, remember, is x bar, which we would get from a sample, minus mu, which we would get from a null hypothesis, over S, that would be the sample standard deviation that we would compute from a sample, divided by the square root of n, and n would be our sample size. So I think we'd be all good to go here with the t-distribution. The degrees of freedom would be the sample size less 1 again. Let's take a hypothetical problem and see how this works out. So I've typed in a problem right here. A sample of 40 cookies is selected from a bag of Chips Ahoy low-fat cookies. It's suspected that the low-fat part comes from less chips than in the regular cookies. We know that the regular cookies have a mean number of chips equal to 24. Well, we have the hypothesis that the low-fat cookies will have a mean number of chips that's less than 24. To test this hypothesis, we're going to take a sample of 40 chips and we're going to find the sample mean to be 19.6 cookies and the sample standard deviation to be 3.8 cookies. And we wish to use an alpha level of 0.05 to conduct this test. So the first thing we have to do to test hypotheses is, logically enough, we've got to have a couple hypotheses. And so we're going to make the hypothesis. One of the things we're thinking about is that the mean number of chips, mu, is less than 24 chips per cookie. Now here's a thing to remember, because this never changes. The null hypothesis always contains equal. One hypothesis that we're testing here is that mu is less than 24. That's what we think, but we're going to have to make that an alternate hypothesis because the null hypothesis always contains equals. So the null hypothesis would be mu is equal to 24, and the alternate hypothesis would be that mu is less than 24. I think that all makes sense when we stop and think about it. Equal has got to be in the null hypothesis because hypothesis tests are always conducted given the parameter that you find in the null hypothesis. And then with mu equal to 24, we're going to see if our results are plausible or if they're implausible. If our results are unlikely, we're going to reject the null hypothesis. If our results are likely, then we're going to have to say, well, there's nothing here to make me want to reject this null hypothesis. So that's how this always is going to work. And now I'm going to write down here, just for reference, what my alpha is so that I'll always remember and so that people reading this can see what my alpha was when I was making these decisions. Now we've got not data, but we've got summary data, not raw data, but we've got summary data up here. So we're going to use that summary data and we're going to calculate an observed value of t. Now what would the observed value of t be? Well, remember that it's my custom to put a little star or an asterisk on the observed value of t. So here's our observed value of t. T is equal to x bar minus mu s over the square root of n. So x bar, I'm reading the problem, and the problem says x bar was 19.6 cookies. Now minus mu. I always get mu from the null hypothesis, so mu is 24. 24 cookies divided by S, the sample standard deviation. The sample standard deviation is given in the problem as 3.8 cookies divided by the square root of n. Now I'm going to erase that n because n is the sample size, and we know what that is. For this example, we've got an n of 40. So there's the t observed. You want to know what that is as a number? Okay. This value of t, when I computed it with the calculator, is negative 7.32. Now, without doing any real computation, I think we can just rely upon our memory of the t distribution and figure out what's going to be happening here. So let me just sketch out a t distribution for you. Now t looks almost like a z, so the t distribution would look something like that. Now this would be t, and what are the degrees of freedom? Well, the degrees of freedom would be 39. So 39. The t is always centered on 0, and my observed value is negative 7.32, so my observed value is way down here, negative 7.32. Now, how likely are we to get a value of t observed as far down as negative 7.32? Remember, the t is almost a z, and you just hardly ever get a z below 3. That can be said for the t distribution also. This is just not likely. So we calculated this number using the null hypothesis, and it's a number that's just not likely, and so we're going to reject the null hypothesis. Now let's make this quantitative, and I'm going to do it in a way that I think is very sensible. I'm going to use Minitab to calculate the hypothesis test here. So let me pull up Minitab, and then I'll show you how we do this using Minitab. So here's Minitab. Now what do we want to do? Well, we want to do some statistics, and so we'll click that tab, and I want to do, this is still considered basic statistics, and I've selected one sample t. Well, why one sample t? What's our situation? We've taken one sample. We have a sample of fat-free Chips Ahoy cookies, one sample. And we're using a t statistic because we don't know what the population standard deviation is. We know the population has a standard deviation. We know the sample standard deviation. And we know we can estimate the population standard deviation with the sample standard deviation. But if we use that estimation, we have a t distribution, and no longer do we have a z distribution. So the correct response here would be one sample t. Now when I take the one sample t, I get a new menu, and I've got to fill out some things on the new menu. Here's our new menu. We're doing samples in columns. No, we have summary data this time, so the radio button would be summary data. What's our sample size? This was a sample of size 40, so our sample size would be 40. What's our mean? The mean, you have to recall this because I've covered up the problem statement, but our mean said, or our problem said that the sample mean, and that's what this refers to, was 19.6 chips in each cookie, and our sample standard deviation was 3.8 chips. That's calculating the mean and the standard deviation just as you learned the first week of class. Now we want to perform a hypothesis test, and so we've got that button checked. The hypothesized mean, that's out of the null hypothesis, was 24 chips per cookie. Why is that the null hypothesis? Null means no difference. If the fat-free Chips Ahoy and the regular Chips Ahoy are exactly the same in terms of chips in the cookie, then the mean for the fat-frees would be 24 also. So that's my hypothesized mean. Let's go to options, and I've got to show you what the options are here we're selecting. One sample T options. The confidence is 1 minus alpha. Remember, we said we wanted to use an alpha of 0.5, so the confidence is going to be 9.5. This could have been 0.95, but whenever people created Minitab, they used a percentage here, not a decimal, and so it's 95.0. That's a percent, not a decimal. They mean the same thing. Now, what about the alternate? There would be three choices for alternate hypothesis: that mu is less than 24, that mu is not equal to 24, or that mu is greater than 24. And remember, we think that they've reduced the number of chocolate chips, so less than would be our alternate hypothesis. Say OK. Double check that we've got everything filled out correctly. It looks OK to me. Say OK again. And here's the result of the one sample T test. Now we can verify that we're testing the right things. So we've got a test of mu equal 24 versus less than 24. That's correct. We've got 40 for our sample size. The mean of the sample was 19.6 and the standard deviation 3.8. And again, all of that is correct. The T statistic was negative 7.32. We know that because we did that one by hand. It wasn't necessary to do it by hand since Minitab is going to do it for us, but it's a nice thing to be able to verify that everything is correct, and that verifies that I've entered the right data in the right places. And now the p-value. Well, remember, the p-value is the probability of getting 19.6 or less chips if the null hypothesis is true. And a p-value of 0 means that that is just not likely to happen. Now, of course, as always, this p-value is 0 to 3 decimal digits. That's what this is telling me, not that its p-value is 0 to a billion digits. But 3 is a lot of decimal digits. This p is practically 0, and this is the p-value. Practically 0 certainly is less than alpha, and so I'm going to reject the null hypothesis. Let's get Minitab out of our way, and we'll write down what we've learned. So what we've learned here is that the p-value, sometimes called the prob value, the p-value was equal to, I'm going to write that as 0 plus, meaning it shows up as 0 to the number of decimal digits we're looking at. That's less than alpha is equal to 0.05, and so our decision is to reject the null hypothesis. From this data, we cannot conclude that the mean number of chips in Chips Ahoy, I'm not writing all of this, that the mean, we cannot conclude that the mean is equal to 24 chips. So it looks like, in fact, they've taken out some chips in order to reduce the fat. Okay, so I think that's the example here that we want to look at. I hope you learned something by going through this example with me. Much of what you learn is going to be by reading your textbook, paying attention to especially those color-coded items in your textbook, and then watching the video maybe again. So thank you very much for your attention.